Most data and AI systems start their life on a local notebook, but once they move to production, your model is only as good as the network connecting it. In the lab, we talk about accuracies and weights, but in the production grade systems, we talk about networking. So, if you build data or AI systems that need to be fast, scalable, and reliable, we need to understand how the data actually moves across the wire. So, we are going to break down the infrastructure of the intelligence. Think of the public internet as a massive highway. Your data travel alongside Netflix streams and social media pings. It is convenient, but it is exposed. For simple apps, actually, this is fine. But for enterprise AI, we use private traffic. By using tools like virtual private clouds or private links, we can keep data inside our own private secured garden. So traffic isolation is basically instead of using the open web, we use VPC endpoints. So this keeps our data inside our own private network. It is safer because it never touches the public internet, and it is faster because we aren't competing with everyone else's Netflix traffic. And we use subnets as security layers to separate our training data from the public facing apps. So this ensures even if our website is attacked, our core models and data remain locked away. The API is how your systems talk to each other, but the protocol you choose determine the speed of the systems. So REST APIs are the gold standard of the web. They send data in JSON, which is a human readable text. It is great for compatibility, but it is heavy. And gRPC is built for high performance AI. Instead of text, it uses binary data. It is much smaller and keeps a constant connection open between the systems. So if you have multiple AI agents talking to each other constantly, gRPC is the way to go. So it cuts because it cuts down the talking time significantly. And then yeah, we often blame the model for being slow, but often it is the network. So we measure this as the latency. There are three main speed bumps. First one is propagation delay, which is because delay happens because of the distance. Even at the speed of light, distance matters. Let's say your user is in Tokyo and your server is in New York. Still, there's like a 36 millisecond delay. And the processing delay. Every time a secured connection starts, the computer and server have to introduce themselves. So modern protocols like HTTP3 make this introduction much faster, which is a game changer for mobile AI apps. And then finally the transmission delay. So here we don't just look at the average speed, we look at the worst case scenario. Let's say if our data gets congested, uh, even a fast model will feel broken to our 1% of users. So why should we care about subnets or domain routings? Because business value isn't just about model accuracy, it's about the reliability. If you're building a recommendation system for a business, they care about two things. Is my data safe, and is the insight there when I need it? So understanding the network allows you to architect systems that don't just work in a Jupyter Notebook, but thrive in a high stakes enterprise environment. Next time you deploy a model, don't just think about the weights or accuracy, think about the wires connecting the network to. So keep the sensitive data private, choose the right API for the job, and always keep an eye on latency.